In this problem, we're going to sketch the graph of the function shown here. To help sketch the graph, we're first going to determine the intercepts of the graph and where the absolute value function has a minimum or maximum value. So first I'm going to take the given function and I'm going to find the x and y intercepts, and I'll do this by simply replacing either the input variable or the output variable with 0. So for example, to find the x-intercepts, I will replace the output with 0, and I will solve for x by first adding the 1 to both sides. Then, since the 2 is being multiplied, I'll divide both sides by 2, giving me 1/2 on the left-hand side. Dividing the right-hand side by 2, I would get 2 divided by 2, which is 1, so that simplifies out, leaving me with this. Notice that this equation would be true provided that the expression in the absolute value symbols are either positive 1/2 or negative 1/2. So I'll write two separate equations. X minus 1 could be positive 1/2, and then that would make a true statement because the absolute value of 1/2 is 1/2. Or the other solution would be if x minus 1 came out to be negative 1/2, and that's true because whatever value of x makes this whole expression negative 1/2, this would read the absolute value of negative 1/2, which is positive 1/2, and this would read 1/2 equals 1/2. So now I need only solve each of these equations by simply adding 1 to both sides. Adding 1 to both sides of this equation would give me x equals 1.5. Adding 1 to both sides of this equation would give me x equals 0.5. So here are my zeros of the function. These are the x values that make my function 0. If asked for the x-intercepts, I would write them in the following way. Since 0.5 is a 0 of the function, then that's an x value that makes my function value 0. And 1.5 is an x value that makes the function value 0. So plotting these 2 points would give me the x-intercepts of the graph. So eventually I'll draw the graph where the x-intercepts are 1/2 and 1.5. I also want to find the y-intercept of this function. You'll find the y-intercept of a function by replacing the input variable with 0. Having replaced my input value with 0, I will simplify. 0 subtract 1 is negative 1. Then, since the absolute value of negative 1 is positive 1, I get that if my input 0, my output would be 2 minus 1, or 1. This gives me the point 0, 1 as a y-intercept. So that means my graph will go through this point here. Now, normally, the minimum of the absolute value function is at x equals 0, and the minimum is 0. But since I see that they subtracted 1 on the inside of the absolute value symbols, that will move my graph to the right 1 unit. And since they subtracted 1 on the outside of the function, that'll move the graph down 1. So my new minimum point, instead of being 0, 0, if I move right 1 and down 1, will be the point 1, negative 1. Connecting the dots, you can see how I'd graph the absolute value function. But since I'm getting this question from Math AS, let me switch over and type in the zeros of the function, the x-intercepts, and the y-intercept. So here's the question in Math AS. I found the zeros of the function to be 0.5 and 1.5. I'm listing them in numerical order, separated by a comma. Listing these zeros as x-intercepts, as points, that was 0.5, 0, and 1.5, 0, listing them again with a comma in between. The y-intercept was the point 0, 1. To plot the graph, notice where the red dots are on my drawing tool. One of the dots is going to be the minimum value, and then I have to pick a second point. So I'm going to plot my minimum value, which would normally be at 0, 0, but remember that it's shifting to the right 1 and down 1, making my new minimum point 1, negative 1. I clicked, let go of my mouse. I'm going to put my second point at 1.5, 0. Hopefully that's close enough to get full credit. Let me submit my answer. Submitting my answer, I got credit for all of my answers except for the graph. Notice that the y-intercept was supposed to be the point 0, 1. But notice on the answer I supplied, it's a little bit bigger than 1. Let me clear all and try again. Again, starting at 1, negative 1. Moving the graph, the second point is 1.5, or I could move over to 0.5, either one, but this time I'm going to make sure that the graph looks like it passes through the y-intercept 0, 1. I'll resubmit my answer, and this time I get full credit for my answer.